Hi friends, welcome to Civil Engineering and Programming channel. In this video, I will show a demo on how to draw how to draw shear force and bending moment diagrams for very easy loading conditions for the simple supported beams and also cantilever beams. Okay, just you click on this. Just you go for SFD and BMD for the beams. Just you click, then you get a user interface like this. Then you can select first. I want suppose I want to input. If I input some values, then okay, for this UDL of simple supported beam with the UDL, then I have to select this radio button. We can select this simple supported beam UDL. Then you can give load as 10 meters and length is 4 meters. Then just you click on this draw shear force and bending moment diagram. Both will be displayed on the single graph. You can see here, this is the red one indicates the shear force diagram and the blue one indicates the bending moment diagram. You can see here maximum bending moment is WL square by 8. You can see here 20, and for the max shear force is, what is shear force? WL by 2. Okay, that is WL by 2 is 10 into 4 by 2, then we will get the 20. Then similarly, if you want to get the shear force and bending moment diagram for simple supported beam with the load is acting at the center, then just you select on simple supported beam concentric point load. Just you select and you can give I'm giving 10 kilonewton and the beam size is 3.5 meters. Then just you click on this draw bending moment shear force diagram button, then you will get like this. You can see here. Okay, then if you want to clear this graph, just clear graph. Okay, again, this is the shear force and bending moment diagram for simple supported beam with point load at the center. Then suppose if you want the cantilever beam with UDL, just you give the data in this particular boxes under cantilever beam with UDL. I'm giving 10 meters and giving 3 meters. Then just you click on this draw BFD and SFD. Yes, this is the shear force and bending moment diagrams for UDL for the cantilever beam. Then just you clear the graph and cantilever beam with point load. Just this is a cantilever with point load. Just you give some dimensions or the inputs as load and length. I'm giving 3.5 meters. Then we can get it. This is the shear force and bending moment diagram for cantilever beam. The load is acting at the edge. Okay, then SSB with UVL increasing. Okay, simple supported beam with UVL uniform varying load increasing condition. Just you give the load as 10 meters 10 kilonewton per meter and length is 4.5 meters. Then what we have to do is draw. I can see this is the shear force and bending moment diagram for particular UVL. Similarly, for SSB with decreasing load, then you can give same 10 and 4.5 meters. Then just you click on this, then you'll get. Okay, this is the shear force and bending moment diagram. Shear force and bending moment diagram for SSB with decreasing load. Okay. So in this way we can create many beautiful applications for education purpose as well as for the practical design by using this Visual Basics 6.0, or you can use Visual Basics.net. But what is the disadvantages of this Visual Basic.net is, in Visual Basic.net you don't have this facility to draw our required or desired diagrams. Okay, by manually. Again you have to write the particular code in vb.net to generate this kind of beautiful diagrams with clarity. Okay, this is all about the simple bending moment diagram and shear force diagram for simple supported beam with different loading conditions. Okay, before that I want to explain one thing. Let us select the simple supported beam. Okay, and why we have to draw the shear force and bending moment diagram. That is very important in whole structural design or any other design also. The most important is how much bending moment is developing and how much the shear forces are developing, at what area the shear force is developing, at what area the maximum bending moment is developing. According to that, we have to provide, or we have to detail. Okay, we have to cut, or we have to provide the stirrups, how much spacing the stirrups is more or stirrups are less. All depends upon the shear force and the bending moment diagram. Okay, if you understand this simple supported beam with UDL, then you can see here at the supports the shear force is maximum. You can see here the shear force is maximum, but the shear force is decreasing when it proceeds to the center span of the beam. You can see here. Therefore, at particular distance we have to calculate. At particular distance we have to provide the stirrups spacing is more. Generally 300 mm we have to provide. Okay, at the supports, near to the supports or the particular length, we have to provide the spacing of the stirrups should be less. Okay, by this how can we decide that is by seeing this shear force and bending moment shear force diagrams. Bending moment diagram, we have to provide the main reinforcement. We have to provide the main reinforcement at the bottom, central reinforcement, because there the bending moment is more. The maximum bending moment or bending moment is more. Therefore, we have to provide here the tensile reinforcement, the bars. But here we can curtail, means we can give the crank, or we can just cut the bar at particular distance from the supports, because at those points the maximum bending moment is nearly very less. Therefore, we don't require, just you cut here. That is called curtailment of the bars. Okay, this is all about very simple thing. Okay, how to draw the shear force and bending moment diagram for simple supported beam with different conditions. Okay, anyway, thank you for watching this video. Thank you.